Thank you everyone for being here. Today the session is about the state of voice interactions on Android. And basically it's what's possible technically to integrate in our own apps today. Everything surrounding voice. So I'm Elaine, I work at Sphere here in Paris. And I work with mobile projects around Android or Flutter. You can follow me on Blue Sky, send me an email. If anything interests you or you have any questions, don't hesitate to ask any questions on any socials, on LinkedIn as well, if you'd like. Okay, so first of all, why? So as I said, the session is about integrating voice and what is possible to do on Android today. But why should I even care? I'm going to be giving you a few reasons to why you should care about this. First of all, hands-free actions on very specific contexts, as in the car, you're driving, maybe you want to interact with your phone, you can do it by voice. Or at home, when you have your hands occupied, you're cooking, or you have your hands busy with something, really cool use case to be using voice as well. So this touches basically everyone. Also, voice capabilities make our apps more accessible for people who may have some kinds of disabilities, such as maybe people have some dexterity problems, some motion problems that they cannot touch the screens and they cannot interact with the screens in a usual way. So using voice can allow those people to interact with those with our apps the same way every other user can do. And lastly, I think today we have a lot of possibilities, a lot of technical stuff that is available out there that allows us to build really cool experiences by using voice. Using voice is fun. You can build games, you can build storytellers and so on. So building voice-rich experiences to your users. And what do I need to do to build a voice-forward or a voice-first app on Android? Basically, there are four blocks or four main features that you can or you should integrate in an Android app if you want to be interacting with voice from start to end. Not all of those blocks are actually mandatory. You see you have several blocks, but not all of them are mandatory. You're going to be seeing this diagram a lot this talk. And we'll be going through technical solutions to be using each of those things right here, but just bear in mind that this is the complete solution where you go from basically your phone is maybe locked and you want to start listening. Your phone is not going to be always listening to a command to interact with your app because your app isn't actually open, so maybe you have some kind of command to open the app and then to start listening. This is the wake word detection. Then you have the heart of the voice detection, which is transcribing what the user says with their voice to an audio file, some kind of audio that is automatically going to be transcribed to text. So this is the speech to text part. So basically speech to text, the voice to text. And then chances are is that you are allowing your users to use natural language to say whatever they need to do with your app, search for something, open things, oh, I would like to do this, I would like to do that. And the better, well, it really depends on the use case, but the best way to think about this is that you're going to allow your user to express themselves the way they want. And in order to extract the meaning of what they said with natural language, there are chances that you're using this block right here, which is natural language processing, which is basically taking the text, I would like to order pizza, and then you are transforming it into an intent that is basically order pizza, maybe. Then you get this intent, you do your business logic, you call backend, you do whatever you like, and then you get an answer back from your services, back from your backend. This answer, there are chances that it's going to be a text as well, and then you have to build your voice answer back if you'd like again, and this is going to being transformed back to a speech by this very last block here that is called text to speech, and basically the user can hear back the answer from your system. So again, this is the complete way of interacting all the way through voice with Android apps. It is 2025, and it will not be a 2025 talk if I didn't talk about LLMs and GenAI. The particular way that we can think about LLMs in voice-forward apps is that it can actually, in some way, replace what I was telling you, when you give your system a text and then it's transformed into an intent. I would like to order pizza, becomes order pizza. This is the machine learning, this is NLP. Maybe for other use cases, maybe I think everyone here is very familiar with ChatGPT, with Gemini, and so on. You can also integrate LLMs instead of or with NLPs. Just bear that it is not detecting the intent. Maybe it's doing like LLM stuff, just, you know, LLMs, large language models, they know a bunch of stuff. They can answer questions, they can summarize, they can do a lot of things like this. We talk a lot about those models today, but maybe they do not fit your use case, but you can integrate them if you'd like. And if you'd like to use those technologies as well. There are some other secondary features that you can integrate as well, such as voice activity detection. When you are giving when your app is listening to the audio, when your app is basically it's listening, and then you have an audio file or have your audio stream that is mixed. You have noise, you have speech, you have dog sounds, you have background noise. There are solutions that are specialized on detecting only the voice activity. Also, there are a lot of solutions where you can actually detect the language the speaker is speaking. There's also speak diarization. Basically, what this means is that if there are several speakers that are talking with your app, you can separate those. Speaker 1 said this, speaker 2 said this, and this is what the speaker diarization is about. In the GenAI era, in order to, if you would like to integrate LLMs in your voice system, you also have to be thinking about the way you're going to be, the way your user is prompting your system. So a lot of thought should be given to the prompt design. Also very advanced, haven't seen anything we as developers can use today, but some use cases could even allow interruptions. Technically, I've seen some demos, but integrated in very complex systems. For example, if you have an app where you're with a kid or with children, and you would like to talk to your app and say, okay, create a story about a teddy bear that is on the forest, blah, 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 so on, so on. Your app can get this task, can create the story, and starts telling the story. And maybe the app will be telling the story for 2, 3, 5, 10 minutes. And then while your app is talking to you, is telling the story, maybe you say, oh, actually the bear, it's not a bear, it is a horse, and so on. And there are, I know I think it's pretty early today to be talking about this, but managing interruptions, basically when the system is talking to you and then you interrupt the system, it gets another input from you and it adjusts the answer, this I think is going to be stuff that we're going to be seeing more and more, and it's going to be more and more available. Okay, so I give you the basic framework of all the blocks, of the different features that you can integrate on in your Android app, but how do I actually do it? I like to see this as developers, we can have 3 strategies. There are voice platforms that exist already. They are not like they exist, they have their OS systems, and as developers, we can integrate as a product. We can integrate with those platforms. Of course, but we are developers, we want to integrate in our own apps, so we're going to be going through first-party and third-party solutions, and there's also with a bunch of, with all of the developments that have been done in the past few years with AI, you can actually do it yourselves. So, integrating with existing platforms, there are voice-forward existing platforms that exist, such as the Google Assistant, Alexa, and Alexa Plus, that has been announced, I think, a few months back. You can look, they have their own ecosystems into integrating. We're going to be taking a closer look at the Google Assistant. If you are building, if you are thinking about building voice interactions with your apps, there are high chances that you are actually thinking about, well, natural language interactions. So you can also integrate with chat applications, such as Facebook, Telegram, and so on. But we are developers, and this is the most interesting part, is actually integrating our own apps with APIs either from Android or Google or from other vendors. And there's also some in-house development that we will be seeing at the end. So let's start with what's possible on Android with official APIs and with also solutions provided by Google. So this is a timeline showcasing everything. All the APIs available on Android are here in green. What you can see right here in 2009, 2010, so a long time ago, it's actually when the text-to-speech and speech recognizer, so speech-to-text APIs were first introduced on Android. So basically those APIs are there since basically the very first versions of Android, and we can actually integrate with them since ever. What was interesting to see that those APIs, especially the speech recognizer one, they got some updates on those past years in order to make them available on device for on-device recognition. So you see right here in 2020 we had the Create on Device that was added. For Android 13, we could get the supported on-device languages, and then language detection as well in 2023. So really cool to see that even though those APIs are very old, they're still being updated, and we have some cool new capabilities such as recognition on device, if, of course, the phone allows it. And what you can see here as well is, well, of course, the birth of the Google Assistant almost 10 years ago now. The emergence maybe of ML stuff in 2017 with Neural Networks API, TensorFlow Lite, and MLKit in 2018. And of course, again, those past few years, the launch of Gemini and Gemma, which is the open model by Google, and the latest versions this year, Gemini 2.5 Pro and Gemma 3 that are available. Also in 2023, we got the launch of MediaPipe. MediaPipe is basically a set of tools, cross-platform tools, not only for Android, they are also for iOS, web. And they allow developers to integrate a bunch of AI features to be run on device. A lot of them are about image recognition, but we are going to see there are some that are about audio. And also I'm going to be talking a little bit also about voice access, which was launched in 2018, which is an accessibility feature I didn't know about. It's actually kind of old, and I think it's pretty interesting, and I think it covers a lot of use cases. So basically, if you go back to our main diagram right here, we can actually use stuff that is already available either on Android as a feature or as an API, such as a speech recognizer for the speech-to-text, the text-to-speech API for text-to-speech. And, yes, I forgot to talk about, but there was also Dialogflow, which basically does the NLP part. It takes a text and it transforms to an intent. This is by Google. This is on the GCP today, on the Google Cloud Platform. So you can have like a 100% solution by Android or Google. So this is what I was talking about. Voice access is an accessibility feature that you can turn on your device, maybe for specific use cases. You can think about, okay, maybe I know that I won't be having access. Maybe I'm going to be cooking, and maybe for the next 20, 30 minutes, I won't be able to actually touch my telephone, but I would like to interact with it. Just turn on voice access, and then you can see, like right here, you can see the person gave the command to open Chrome, and then you can scroll down, can tap on things. You have to get used to it. It's basically giving commands to the app, but I thought it was really interesting, and I wanted to share. Maybe as a developer, and if you maybe imagine some use cases that you are going to fulfill for your product, maybe this can fulfill a lot of use cases. So I was talking about the Google Assistant, which is the second assistant we got on Android, because we had Google Now back on the day. It was on my diagram as well. And it still exists today. It's still on. How can we integrate with the Google Assistant? Integrating with the Google Assistant means that we are delegating all of the blocks, all of the technical parts here will be managed by the Google Assistant itself, because it is a voice assistant and it can manage everything by its own. But what is really interesting is that as an Android app, you can actually integrate with the Google Assistant by using this configuration file, this shortcuts.xml file, where you actually you put here the capabilities of your app, and by doing some configuration on Google Play, your app can be linked to the Google Assistant. So basically, when a person is using the Google Assistant, they can say, okay, open this app and do this task. It will basically deep link to the correct screen on your app, or even do an action on your app. This is what the shortcuts file looks like. So you can see it's basically so shortcuts, you are declaring the capabilities. Here you have, on this example, the start exercise capability, and then the intent that you're going to be managing, and some parameters, and one fallback intent with no parameters. And that's it. That's everything that you need to do in order to integrate or make your app compatible with the Google Assistant. Those are the actions that are available today. A lot of health and fitness, as you can see on the example, but also transportation, productivity, communication. So not a lot, actually. It's actually those very specific examples are kind of niche, but we have the Open App feature, which basically launched a feature on the app. So basically every app can actually integrate this. So Google Assistant has their own ecosystem, developer ecosystem, which is called Actions on Google. App Actions is what I just showed you, is the glue between an Android app and the Google Assistant. And what you have to do, as I said, you have to create the shortcuts file, put it in your app, and do some configuration on Google Play, and you're good to go. Of course, with some deep linking, as I said. Actions on Google is the developer platform of the Google Assistant. And it's not Android. App Actions is kind of part of Google Assistant, of Actions on Google, but it's for the Android part. But one very important thing about Actions on Google is the main part of Actions on Google was actually conversational actions, which for those who know also the Alexa world will be like Alexa skill. They have been deprecated for almost 2 years now, and so almost all of Actions on Google are actually deprecated because those extensions, when you actually are not using your Android app, you're only talking with your the Google Assistant, and it's making some server calls, and maybe you have a Nest Hub or a Nest device in your house, you're going to be launching, I don't know, your custom app. You could before have custom apps for the Google Assistant, you cannot anymore. But App Actions are still there, they still work. But the thing is that we have a new assistant today that is called Gemini. So what about Gemini? For folks like me who have both or used to have the Google Assistant app and you have maybe installed the Gemini app in your device, you got this experience right here where basically you were invited to replace the Google Assistant with Gemini because yes, you can only use one at a time. And then I think everyone is familiar with the experience of Gemini. It's an app, you open, you ask questions, you have fun, and so forth and so on. When you are on this screen right here, there are some capabilities that come out of the box. You can say to Gemini, you can ask Gemini, you can say, open some app, and it will open, and then you can maybe trigger something to start listening inside your app. But you also have, when you push this button right here, you start the live interaction with Gemini, where you have like this uninterrupted live conversation with Gemini. Here, you cannot quit Gemini. You stay here, and you cannot say, okay, open my app. You stay here. Today, maybe it will eventually evolve. Okay, but this was Gemini app, and the only thing that I can do is maybe opening the app. But inside of the app, if it makes sense to you, because we're talking about LLMs here, so very specific use cases, you can try the Gemini API. The Gemini API is not the objective of this talk, talking about the LLM APIs. I just wanted to show you that this is available out there, and specifically, Gemini API can also get as an input for all of these models right here, it can get audio. So basically, your Android app can use not the speech-to-text APIs, but the media recorder API to record something from your users, then send it to the Gemini API, and do this stuff right here. But what you will do would describe, summarize, answer questions. You know, there's a very limited use cases. This is if you want to send the audio. Of course, you can also do the speech recognition in your device, so you can first transform it to text and then send as a text to Gemini and do whatever you like. So basically, this is what is happening. If you use audio, it is replacing both blocks here, the Gemini API, for very specific use cases, those that we can use with LLMs. There are ways, so this is calling APIs that are on the cloud. There are ways of running models on device. Gemma is an open model, the open model by Google, sorry, and MediaPipe, as I said, is a set of tools allowing developers to run AI on device. And there are ways of running Gemma on device with MediaPipe. What is interesting here is that everything runs locally, so you can make LLM inference locally on your Android device. But of course, one thing that you should be aware is that those models are actually very big. Maybe you're going to be using those models. I think there are 4 or 5. I think there are 4 Gemma models, yes, with 4 different sizes. Maybe the very first one is the smallest one you can actually put in your app, but it's still quite heavy. in size. There's also Gemini Nano, just wanted to point it out because it's available, but it's super niche, only available on very specific devices where you can do local inference as well. This is the difference with Gemma is that Gemma is an open model that can be used by all of the devices, and you can actually customize it if you'd like. Gemini Nano, it's something that is coming already present in some specific devices, and you can do LLM inference on device. As I said, MediaPipe has also some audio tasks. Actually, has exactly one audio task, which is the audio classification guide. This is where you can maybe detect if there is human speech coming from whatever you're trying to record or whatever you're trying to do in your app. Again, MediaPipe is completely working offline, so one advantage here is that this works offline. And to end with all the Android forward or Google forward solutions, yes, you can, if it makes sense to you, you can basically do cloud, you can use the cloud directly. You have the cloud speech-to-text and text-to-speech. They are really, really, really powerful. They can do a lot of stuff, but of course, it requires the connection, it requires sending the data to the cloud. So, but just so you know, they exist and they make, maybe they make sense for your business. So this was only the Google solutions. I think as Android developers, this is what I wanted to showcase every one of those solutions, because as Android developers, we are using the Google solutions. So chances are those solutions will work best or will integrate best with our Android apps and with the Android system. So this is why I think we should be taking a closer look to those ones, especially MediaPipe, of course, all the Android features and Android APIs. And I would really like for a new version of App Actions with Gemini, so we'll see. But of course, there's more out there than Google, right? There's a lot of other actors that are working on this space. So I'm going to be giving some examples. There's a lot more there's out there. I'm going to be showcasing some other solutions that are out there on the market. So again, those are the 4 things that you need to integrate in order to make a full voice experience. And we'll be taking a look at technical solutions or solutions to each one of those. The very first one is called a Pico Voice. Pico Voice is really impressive solution because they are basically doing everything I put right here on the top. The solutions that are the blocks that are being implemented by the solution that I'm showcasing, and you can see that they're doing everything and offline. I really encourage you to test it if you want to choose one, of course, besides all the Android stuff, because this is the main APIs, and I think for a lot of use cases, this is actually enough using the speech recognizer and text-to-speech from Android. This one is really impressive. They have demos where they're showcasing everything that they do. They have a free tier, so you can actually just go to their website and try it on. Really cool, and again, everything is happening offline on device, so pretty impressive stuff. I was talking about Google, but there are the other giants of technology, such as Amazon and Microsoft. They both have their own solutions that are brilliant, they work very well on the cloud, so you can take a look at those as well for on AWS and on Azure. Yes, and I was kind of happily surprised when I was looking at the Azure doc. They even have a keyword recognition. This is kind of a very niche thing to be tackling, and they have a solution to that. So really interesting to see Microsoft doing those solutions there for Android. And each time, oh, I didn't say, but each time there is a demo or an example of Android code, I put it here. Maybe the most popular speech-to-text API today is the one by OpenAI. It's called Whisper, and they are available. It's available on various sizes as well. The smallest ones are only available in English. You have to go large or turbo to get other languages. And you have a bunch of examples of folks using the speech-to-text capabilities from Whisper, which I hear is very impressive, by OpenAI, and integrating it in an Android app offline by not using actually the API call, which is quite impressive. A shout out to a talk by Voyage SNCF, so a French company. When I first started being interested in all this NLP voice stuff, they already had this this project maybe 5 or 6 years ago, and still out there, still active and open source. So they're doing a lot of natural language processing compatible with a lot of open standards, which is awesome. I took a look at their code. A lot of their code is actually written in Kotlin, which is pretty cool. And they provide both speech-to-text and NLP. So really cool to see Voyage SNCF doing it. If you ever use the chatbot on Voyage SNCF website, Talk is powering this chatbot. If you think you had not a very nice experience, so you can actually look at the code and maybe find some improvements and send a PR to the team. Meta, Facebook, so Meta has their own NLP solution as well. It's called Wit.ai. This one is a speech recognition toolkit that supports more than 20 languages. What is interesting, it's 50 megabytes for each language, which is, I think, is pretty cool. It's working offline. And what it does as well, it does a speaker identification also. Besides speech-to-text, they're also doing speak diarization, so pretty interesting. You can take a look at this. This one is doing voice activity detections offline, and this one was offline. Offline as well, yes, because I said 50 megabytes. This one offline as well. It is from an audio sample that is being run. It can identify the presence of a human voice. So, and again, everything offline on this one as well. Okay, so this was for the third-party solutions that exist out there that people are using, more or less. And again, when I used to talk about this, I said, yes, and if you have some machine learning, AI development expertise, you can do your own models, you can customize your own models. But I didn't talk about this because it was, for me, too far-fetched. It was maybe too complex. But today, I think, with the democratization of all the tools that exist out there, we can actually maybe tailor something to our needs. And one of the resources that I think are really invaluable in order to do in-house development, or basically doing whatever you need with tools that are out there, is actually Hugging Face. If you go to Hugging Face is a very known, a very big platform on AI and GenAI stuff. One of the things that they provide is that they provide models to do various tasks. I put here the kind of models that are specialized on natural language processing, so all of these tasks can be done, and also on text-to-speech, text-to-audio, automatic speech recognition, so basically speech recognition. And there are so many things out there. I put some examples of the quantity of models for one category right here, 90,000, 20,000. There are so many. Maybe you're going to be using something, or you're in France, maybe you're using something that I only need a speech recognition for French, only speech recognition for French for a specific thing. And maybe you can find things out there. There are a lot of tutorials, a lot of things that are available that we can actually customize and integrate in our apps. If you do like to use models that are available on Hugging Face, chances are, in order to integrate those models on Android, you will be going, you have to know some TensorFlow Lite as well to integrate them. But again, there's a bunch of tutorials out there that can help you with that. And this actually empowers people. I think with all of the advancements, with everything that is out there, this has empowered a lot of people to actually build their own assistants, build their own solutions that work on their devices. It can be, of course, Android, but it can be Raspberry Pi or whatever. And I think it's so cool to see everything that everyone has done to basically build their own device that is running local LLMs, that is running local voice recognition, and so on and so forth. It's awesome to be seeing all of this being developed. But to wrap up, again, this was what we went through today, all of these features right here and the technical solutions that go with it, either Android, Google, or third party. And just, as I said in the beginning, you don't have to do everything. Think about a use case and think what features you actually need. Is the app going to be closed? Is the app already going to be open? So you have two examples here with the app open, with the app closed. Maybe you're going to be giving back a visual answer to your user, so you don't need text to speech. So this is just some examples to show, and actually with some technical solutions right there, that you can actually mix and match, and you don't need everything. Just implement what makes sense for your use case. Again, some other examples right here, just to illustrate what you can do. In conclusion, one of the inspirations that I had for this talk, again, I said I talked a lot about this topic a few years ago. And with everything that we have now in AI and stuff, I said, oh, I really want to build something cool using voice. So this is, well, I put interesting use cases because basically this is what I want to build, some of this. Voice-rich experiences, as I said, one of the most common use cases is actually creating stories for children because it's so easy and it's actually fun using GenAI, Gemini, ChatGPT, wherever you ask. Maybe you can even tell your kid, I don't know, to say, oh, I want a story about the princess that is in the castle and so on, so forth. And you can have a really rich voice experience like this. Games as well. I think I've seen some games based on LLMs and stuff, but by using voice, I think it would be so fun to be building those. And on the other side, because this needs actually LLMs with a lot of data to be able to generate stuff, but on the other spectrum, you can actually have small models that can run on device that can allow some really interesting experiences for some use cases, such as when you're learning a language, maybe you can download a model that is really, really small that maybe has the recognition for, I don't know, 100 words or 1,000 words said in one specific language, and you can actually put this really small model inside of your app and make an app that to do a pronunciation exercises to learn a new language. And again, hands-free action for cooking, or maybe you're too lazy, you're on the couch, you don't want to go take your phone that is on a table for, maybe talking, commanding your phone. It could be a really cool experience as well. So basically, what you saw here was a lot of solutions that I think pretty mature today for speech recognition, text-to-speech, that have been, again, as I said on the beginning, they have been on Android since Android is Android, basically. But they get better and better through time with on-device stuff that gets added. But the latest things that we have seen is actually people getting interested in building their own voice assistants. The thing that we'll have to see for the future is that, again, as I said, we are Android developers, so maybe integrating with some kind of Gemini feature in order to basically mix and match, glue Gemini with their with their Android app would be awesome, just as app actions. And my personal point of view is that in the era of personal information getting everywhere and people being really scared about devices that are always listening and then can say to Microsoft, to Amazon, or to Google, I think offline is key. I think it will, for me, I would love to be working on offline experiences. I think today our phones are capable enough to do basically everything that I showed you here today offline. And yes, we'll only be seeing more and more things being developed on that feature there. But again, it would be great, in the meantime, it would be great to see more efforts integrating the voice assistants that we are really working hard on creating right now with actual apps that we know how to build. But in the meantime, just keep building. And thank you.
Hello, thank you so much for the talk. I had a small question, like, is it possible already to use the Google solution for KMP, just for Android and desktop, or still not?
Which one?
Wait, let me look. Zema 3, yeah. Zema 3 and MediaPipe.
MediaPipe is available as an Android. They have the Android lib. You have to check. I actually don't know.
Okay.
But there's an Android. Maybe it's available. Good question. Yeah. But I don't know.
Thank you very much for this talk. It was very interesting. My question is about wake-up word detection. Do you have any experience with third-party wake-up word detection? And if so, do you have any recommendation on that?
Yes, the only one I actually tried a few years ago was this one from Pico Voice. I think I actually don't know if they still work, because they say that they have the wake word detection. I would look at this one and maybe at this one here, keyword recognition from the Azure. But technically, I think your app has to be open first. But I think I tested this one a few years back. It worked really, really well. So I recommend this one if you want.